Greetings, everyone. Welcome to today's presentation. When it comes to the future of enterprise storage solutions, virtualization integration is an essential trend that cannot be overlooked. In this space, QSM4 stands out as a powerful platform that seamlessly connects virtualized environments with storage architectures. It not only enhances resource utilization, but also simplifies management processes, enabling businesses to achieve greater efficiency and stability. Today, we will dive into how QSM4 leverages virtualization integration to deliver game-changing value. With the growing demand for flexible and scalable storage solutions, VMware's SE 8.0 emerges as a robust hypervisor designed to optimize virtualized environments. It offers enhanced performance, better resource management, and improved compatibility with modern IT infrastructures. One powerful use case is the integration of QSAN's ISCSI storage systems with ESXi 8.0. This combination provides an efficient solution for businesses to manage virtualized workloads. Through this integration, you can 1. Connect an ISCSI LUN from QSAN storage to an ESXi 8.0 host. 2. Configure it as a data store. 3. Use vCenter 8.0 to deploy and manage virtual machines with ease. This seamless setup delivers significant advantages, including centralized storage management, high availability, and optimized performance. In today's session, we'll guide you step by step through the process, helping you unlock the full potential of virtualized infrastructures with QSAN and VMware SE 8.0. We can see a simple and intuitive topology that illustrates the connection between SE 8.0 and the QSAN storage system. At the core of this architecture is the VMware SE host, which manages the resources and operations of the virtualized environment. Connecting the ESXi host and the storage system is a switch, serving as a network bridge to ensure data is transmitted efficiently and reliably to the underlying QSAN storage device. This design not only simplifies the connection process, but also delivers reliable performance and efficient resource utilization, providing stable support for virtualized workloads. In the following sections, we will dive deeper into the step-by-step configuration process. During the virtualization process, businesses often encounter numerous challenges. First, time consumption is a significant issue. With the increasing demand for high-speed data, setting up and managing equipment upgrades requires a considerable amount of time, impacting overall efficiency. Second, there are limitations with outdated hardware. In many cases, older devices cannot be fully phased out, which hinders overall hardware performance and becomes a barrier to further upgrades. Additionally, extra costs must be considered. To maintain data portability and implement a flexible device strategy, businesses need to invest additional resources in integrating existing and new devices, adding to the financial burden. Heavy server loading is another common challenge. Virtualized architectures or databases often generate a massive amount of I/O requests, making it difficult for storage devices to handle the load and ultimately affecting the performance of the host server. Lastly, there's the issue of unstable output. To address system latency and performance issues, equipment managers frequently need to manually adjust the resource allocation of storage devices to meet demands, which is often insufficient to fully resolve the problems. The integration of VAAI, VMware vSphere storage APIs for array integration in QSAN storage delivers dramatic performance improvement for your VM environment. It becomes easier to achieve granular control, backup for individual VMs, and policies management based on storage guidelines, plus the flexible data portability. The greatest part is that it is built in without any extra cost. Through the vVol's VASA provider, storage devices can be uniformly controlled by vCenter to achieve flexible storage resource management. ESXi hosts no longer passively accept LUNs created by storage devices, but can create the vVol that VM needs according to the vCenter SPBM. Then establish a more unified, more refined, and more flexible storage strategy driven by vCenter policies, allowing external storage devices to be integrated into VMware's architecture. We will show how to OCN-figure QSM4 with ESXi in next part. Go to the vCenter 8.0 management page and add an ESXi 8.0 host. Go to the storage adapter and check VMHBA64, then select Static Discovery and click Add. Enter the IP for storage data transfer port, and then copy the host group's IQN from the storage and paste it into the ISCSI target name field. After rescan storage complete, go to the Storage Devices page to verify that the ISCSI LEUN has been successfully mounted in ESXi. Right-click on the SRI host and add data store, select the ISCSI LEUN, which just mounted. After data store is created, right-click on the data store and create new VM. Configure the VM detail setting and click Finish. In conclusion, the integration of QSAN Xcube NXT with VMware ESXi 8.0 simplifies virtualized environment management, offering scalable, high-performance storage solutions. By following the steps outlined in this guide, businesses can efficiently configure ISCSI LUNs as data stores and deploy virtual machines through vCenter 8.0. This approach enhances flexibility, centralizes storage management, and ensures high availability, making it an ideal solution for organizations looking to optimize their IT infrastructure and improve overall efficiency in managing virtual workloads.